Okay, notes 2, the addition rule. So first we're going to talk about mutually exclusive events. So it says when two events have no outcomes in common, we refer to them as mutually exclusive events. So you would see the formula as the probability of A and B is 0, or you could see this as the probability of A or B, which is the probability of A plus the probability of B. So let's look at an example. It says, let's revisit our rolling 2 dice game where the italicized numbers represents the sum of the dice rolled. Okay, so it takes each of the dice and adds them together. Okay. A is rolling a sum of 5, and B is rolling 2 even numbers. Are these events mutually exclusive? We would say yes, since they have no events in common. Or in other words, look at A, rolling a sum of 5. Okay, well, what are the only ways we can roll a sum of 5? We could do 1 plus 4. We could do 2 plus 3. I think that's it, right? 1 plus 4 and 2 plus 3 will give us a sum of 5. Well, the other event is rolling 2 even numbers. Well, if we look back at this event, notice that we have odd, even, even, odd. So they're not going to be 2 even numbers. So this is not going to occur at the same time, which means that they are mutually exclusive because they have no events in common. So now let's look at the probability of A, rolling a sum of 5. So I would look over here, okay, rolling a sum of 5, let's see, 1, 2, 3, 4. That would be 4 out of 36. And the probability of B, rolling 2 even numbers, would be let's see, change the color here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be all the possibilities of rolling 2 even numbers. That's 9 out of 36. So the probability of A or B is the same as saying the probability of A plus the probability of B. So this is equal to 4 over 36 plus 9 over 36, which would be 13 over 36. Or, of course, we would reduce that to a decimal, and that would be 0.361. Okay. Example 2 says identify if the following events are mutually exclusive. If they are not, give an example where they overlap. So rolling a sum of 4 and rolling doubles. We would say no, because you could roll a 2 and a 2. 2 and a 2 will add to 4, but they're also doubles, so not mutually exclusive. Part B says rolling an odd sum and rolling a 3. Okay, not mutually exclusive. Why? Well, rolling an odd sum means we have the possibility of rolling a 3 to be included in that sum because 3 is odd. For example, we could roll a 3 and a 2. Okay, 3 and a 2 gives us 5. That's an odd sum. 5 is odd. But when we rolled a 3, to get our 5, they overlapped, so it's not mutually exclusive. C, rolling a 4 and rolling a sum of 12. Okay, this is mutually exclusive because the only way to roll a sum of 12 is if you have 6 and 6. Okay, there's no way of rolling a 4 if you have to roll 2 6s. And then part D, rolling an odd number and rolling a sum of 10. Okay, well, no. That's not mutually exclusive because in order to roll a sum of 10, for dice, let's see. For dice, it would have to be, I think, just 5 and 5. Okay, 5 and 5 would add up to a sum of 10, but 5 is an odd number, which means they overlap, so it's not mutually exclusive. Okay. Then it says, how do we find the probabilities of non-mutually exclusive events occurring together? Okay, well, in order to answer that question, we are going to look at example 3. It says, find the probability of rolling doubles or a sum of 6. Okay, so this should look familiar because this was the game that we played and these were the rolls. Okay, rolling doubles or roll a sum of 6 and then you beat the teacher. Okay, so it says, are these mutually exclusive? Okay, well, remember we said that rolling doubles and rolling a sum of 6 had one overlap. And remember that overlap was when we rolled a 3 and a 3. Okay, those are doubles. But 3 plus 3 is equal to 6. So that was the overlap. And since we have a overlap, we would say no, it was not mutually exclusive. Okay. Remember in our lab, we said the probability of A happening, which is the probability of rolling doubles, was a 6 out of 36. And the probability of rolling a sum of 6 was 5 out of 36. Okay. The probability that they occur together, that's the probability of A and B. This is the overlap. Well, remember we said there was only one overlap, so that was 1 out of 36. Okay. And then the probability of A or B is still going to be probability of A plus probability of B, but we need to subtract the overlap. So subtract probability of A and B. Okay, so that means we have 6 out of 36 plus 5 out of 36 minus 1 out of 36. Okay, which gives us 10 out of 36. Okay, so going back up here where it says, how do we find probabilities of non-mutually exclusive events occurring together? Well, we have to subtract the overlap. Okay. General addition rule. So it says if A and B are two events resulting from some chance process, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. This right here is the addition rule. Okay. If A and B are mutually exclusive, the probability of A and B is 0, which means that the formula for probability of A or B is probability of A plus probability of B, because technically subtracting 0 does nothing. Sorry, excuse me. How do we know the value of probability A and B? For now, we just use common sense. Okay, later we'll learn about the multiplication rule. So let's look at example 4. It says a card is selected at random from a deck of 52 cards. Determine if the following events on the next page are mutually exclusive and then find the probability of the events. Okay, and here's a deck of cards in case you are not sure what is in a deck of cards. So we have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and then in 4 different suits, clubs, spades, hearts, diamonds. So the first one is, what's the probability of getting red or a queen? So we would say, no, this is not mutually exclusive because a queen can be red, so there's overlap. So if you need to pry that because of the overlap, queens are also red. Okay, so the probability of getting red is 26 out of 52. That's half the deck. The probability of getting a queen is 4 out of 52. The probability of red and a queen, okay, is 2 out of 52. There's only 2 red queens in the deck. And the probability that it's red or queen is going to be 26 out of 52 plus 4 out of 52 minus 2 out of 52, which gives us 28 out of 52, which is a 50.538, or about a 54% chance that we pick a red or a queen. Okay, then we look at king. Okay, sorry, not king, B. Probability of an ace or a king. Well, we would say, yes, that's mutually exclusive. You can't be both an ace and a king. Well, the probability of an ace is 4 out of 52. The probability of a king is also 4 out of 52. So the probability of an ace or a king is going to be 4 out of 52 plus 4 out of 52. And since there's no overlap, we don't have to subtract anything. So the probability is 8 out of 52, which is 0.154. Okay. C, probability of getting a queen or an even number. Well, yes, this is mutually exclusive because you can't be a queen and a number at all. Okay, queen is separate than a number. So the probability of being a queen is 4 out of 52. Probability of being even, okay, is 20 out of 52. And if you need to go back up here and count these cards visually because you're not sure what a deck of cards looks like, please feel free to do that. Okay, which means that the probability of queen or even is just adding the two together. So 4 over 52 plus 20 over 52 is equal to 24 over 52, which gives us 0.462. Okay, then we have probability of black or odd number. Well, there are black cards that have odd numbers, so I would say no, this is not mutually exclusive because there is an overlap, and that overlap is that odd numbers are black cards. Okay, so the probability of a black card is half the deck, so 26 out of 52. Probability of an odd number card is 16 out of 52. Probability of black card and odd card, so this is where they overlap, is going to be 8 out of 52, which means 8 of the cards in the deck are black cards and are odd cards at the same time. So the probability of picking a black card or an odd card would be equal to the probability of a black card, so 26 over 52, plus the probability of an odd card, so 16 over 52, minus the overlap, so minus 8 out of 52, which is equal to 0.654. And remember, when you're doing probabilities, you're always putting it in decimal form to 3 decimal places. Okay, last example. It says you were interested in how many students at your school regularly eat breakfast. You conduct a survey asking, do you eat breakfast on a regular basis? Your random sample consists of 600 students at the school, and the results are shown below. If we select a student from this sample at random, what is the probability that a student is female? Okay, well, females, there were 278 of them out of our 600 total, so that is 0.463. Okay, what's the probability of someone who eats breakfast regularly? Eats breakfast regularly is 300 divided by the total, which is 0.5. Okay, a female and eats breakfast regularly. Okay, well, a female and eat breakfast. Well, I look at eats breakfast regularly, and then I look at female. That's right here. Okay, so that's 110 out of 600, which is 0.183. Okay, then it says a female or eats breakfast regularly. Well, remember, that's the same as saying the probability of a female plus the probability of someone who eats breakfast regularly minus the overlap, so minus the probability of female and eats breakfast regularly. And we already did all of those in A, B, and C. So this is going to be 278 out of 600 plus 300 out of 600 minus 110 out of 600, which is equal to 468 out of 600, which is going to be equal to 0.78, or about a 78% probability.